Okay, this is Geometry 4.3, rotations. So we're still talking about transformations or changes. Another type of transformation is a rotation, or like it's more commonly called a turn. Again, that's kind of a slang term for it. But a rotation is a transformation where you're taking an object such as a point, could be a segment, could be a polygon, and it's turned about a specific fixed point. That fixed point is referred to as the center of rotation. So kind of reviewing the other types of transformations that we have for a translation. The requirements for a translation is you need something to translate, and then you need a vector, whether it's in vector form, component form, or even ordered pair notation. Okay, for a reflection, you need something to reflect, and then a line of reflection. And then for a rotation, okay, you need a few different things. You need something to rotate, like a point, a segment, okay, or a polygon. You need a center of rotation, and then you also need an angle of rotation. So for example, I could rotate a point, and I'm going to call it point A, about the center of rotation, point P. So the fixed point is the center of rotation, and then I'm going to say 40 degrees. And then if it's 40 degrees, what that implies is counterclockwise. It's always counterclockwise unless otherwise specified. So sometimes you'll see counterclockwise abbreviated CCW, but if it just says 40 degrees, like I started off with, that implies that it's counterclockwise. If it's clockwise, then it will specifically say clockwise or possibly just CW. Okay, but I have a point P, that's my center of rotation. I have my point A, the point that I want to rotate, and then I want to rotate it at 40 degrees. So that means it's going to go in this direction. But before I rotate point A, here are all the parts that you need in order to be able to rotate something. Okay. I'm going to draw a ray from point P, the center of rotation, through point A. That's actually going to be basically 0 degrees, or my initial ray of my angle. So then I want to now figure out a 40-degree angle, specifically counterclockwise. So in this direction, you need to make sure that you're going in the correct direction. And you also want to make sure that you're making P the vertex of the angle, not A. That's why I drew a ray as opposed to a segment. It'll be, or it should be, a little bit easier to figure out where the other ray should go, and specifically like the center of my protractor, where that should go. So I need to measure off 40 degrees. You can see right here, this is 40 degrees. I'm using the inside numbers because this right here is 0 degrees, 10 degrees, 20, 30, 40. Okay, I'm marking my point here and then making my angle, again, rotating in a counterclockwise direction. So this right here, kind of estimating a little bit too far, but this is a 40-degree angle, specifically counterclockwise. And then what I'm going to do is just measure the distance from P to A. Okay, what I'm going to suggest you use, if you have one, is a compass. So I'm taking my compass instead of using markings on my ruler. It's actually easier this way. If you have a compass, use it. If not, you'll have to use the markings on your ruler, but then you have to remember the distance. But here's the length of segment PA. Okay, right here, that's my fixed distance. And then I just transfer that distance on this terminal ray of the 40-degree angle. I know it's a little bit light, you might not be able to see it that well, but right here, this distance from P2, this would be A prime. So I'm using prime notation just like I would with translations and reflections as well, but PA prime is the same length as PA. If you don't have a compass, here's something else that you could use, just like a scratch piece of paper. Here's the distance. I don't have any markings on here. I have the markings in inches. I don't have the markings in centimeters or anything like that. But then you just transfer that distance to that terminal ray that I made with the 40-degree angle. And that's A prime. So this is a 40-degree rotation, specifically counterclockwise for point A.